Okay, so good evening class. Our lesson for this evening is about, to continue rather our lesson this evening about immune system. So we're going to talk about now the uh, type of immune system. No. So basically, our immune system we use this against pathogens, bacteria, virus, fungi, etc. Okay. So we have the first line of defense. Basically, we have the skin, which is considered as the first line of defense or our covering of the body. Okay, so it is the first line of defense against this pathogen, chemical, mechanical, and other forms of harmful substances that surrounds us. Then you have your second line of defense, which is your non-specific immune system, which includes your WBC, uh, NK cells. So we have also uh, inflammatory response, fever, okay, and phagocytosis, created by the phagocytes or macrophages. These are uh, non-specific immune response. Okay, and then you have your third line of defense, which is the specific immunity, which involve the humoral and cell-mediated immunity. Okay, so immune system. So we have uh, basic terminology, which we have to learn first. We have your cytokine. Cyte means cells. Kin means movement. So these are the moving cells. No? So these are known as messenger. Then we have the lipokine, which is when you say lipo with that live refers to lymph, which is a fluid. Then movement. No, this is our fluid that moves in our uh, immune system. Then you have your monokine, one, the movement. So interleukins, you have between, then leukin means white. So this is between the white blood cells. Okay. So we have here in our immune system, we have chemical messengers, which involves the cytokines. Okay. Then we have also messenger for the B cells and T cells. Okay. Then we have the monocytes and macrophages, which secretes this monoclin and interleukins. Okay. The the basic purpose or primary purpose of these substances are they send messages among leukocytes. Okay. Then, so when you talk of non-specific immunity, uh, when you say non-specific, it is our line of defense which targets not only the bacteria but as well as it could damage the uh, the good cells. So that's why it's called non-specific. So just like throwing a grenade in the midst of of the soldier, or throwing a grenade to a soldier which is in the middle of the market. So although the soldier may die, but at the same time there are a lot of collateral damage, which includes civilians, properties. So that is non-specific. No? Whereas when you say specific immunity, so it targets only the pathogens. So these are snipers. No? They act very specific, or they are the uh, silent killer. No, you get my book. So uh, these are very specific, which targets the the, the pathogens or disease-causing microorganism. So in that specific, you have your mechanical, physical, and chemical. So these are the pathogens, okay, that acts on the body. So, so they cause diseases in our body. No? So example of mechanical. So you have your or rather there are barriers rather. So example of mechanical barriers that protects us against pathogen. You have your sweat, your mucus, your cerumen. So these are barriers. No, so let's take for example cerumen. So they traps dust, microbes, which gets into your ears. You have also your mucus secretions. No, so they trap bacteria that moves into your nose or even to your mouth. No, so that's why you produce secretions coming from the goblet cells. Chemicals. So these are example of these are your tears, saliva. So these are chemical barriers. They have anti uh, white blood cells, which is found in those substances. No? Okay. So let's go now to uh, secondary defense. Then I have your phagocytosis, inflammations, pyrexia or fever. Okay, so pyrexia means fire or fever. Uh, Inflammation, that refers to the inflammatory response of the body. So it is still a non-specific. Okay. Phagocytosis, that is non-specific because when phagocytes engulf, it includes the good and the bad cells. Inflammation, so of course, this is a non-specific immunoresponse which targets the bacteria, but at the same time, it will also damage good cells, which is adjacent to the area damaged. Pyrexia, fever. So as we all know, fever is in non-specific immune response to the body. Okay, so anything that is exposed to heat will die, but at the same time, your normal body cells will also damage. Okay, so one example of that, if you are experiencing, so let's say, not only fever, but experiencing uh, convulsions, no? So usually you suffer convulsion if your body temperature will increase beyond 40 degrees Celsius or 40. So that increase of body temperature will kill the bacteria that causes your body temperature to increase, but at the same time will also damage your nervous system. That's why you suffer from convulsion because your nerve or your neurons fire electrical signals abnormally. So specific immunity, we have two types, humoral and cell mediated. Okay. So again, when we talk of specific immunity, it may be acquired or it might be passive. So when you say acquired, that is maybe acquired to your mother or maybe given to you by uh, so no. So there are some specific immunity that could be inherited. No? Uh, so when you say acquired, you have your vaccination. That's an example of acquired. Also, sometimes exposure to to pathogens. That is an example of acquired. So when you say inherited, so specific race have sometimes specific immunity to certain diseases or pathogens. So cell mediated. Cell mediated. So as I've said before, the bodies are the response of the body or specific response of the body when the bacteria is already within the cell. But when it is outside, then the body will use the humoral immunity or the fluid, no, which is basically antibody mediated. So we have here two types of acquired immunity. We have active and passive. So when you say active, uh, could be form of natural and artificial. So natural immunity, that is basically you subject yourself to or you expose yourself to bacteria or to viruses, so such as herd immunity. You have heard of that, which is very common in this pandemic. No? So in herd immunity, individuals is subject for exposures to the viruses or bacteria so that they could be immune. Then artificial, Malaysia, vaccination. So that's why kanang vaccine karon sa COVID-19, that's an example of artificial immunity. When you say passive or passive acquired immunity, so there are two types. You have your natural and artificial. So natural, that is transferred from mama to baby. That is natural. Artificial, these are immunoglobulin has harvested from a donor who develop a resistance. Let's take for example kanang uh, anti-venom in development of anti-venom, no? So kanang individual nga napaakan sa alas siya o namantay. So usually nanan say artificial immunoglobulin which is found sa iyang blood. So makatabang na siya, no? Extract siya ng immunoglobulins can produce, then it could be administered to other people. Okay, so these exercises, three, and I'm going to give this as an your activity that will be submitted before the end of the final. So these are the basic terms that you could see, when we talk of blood. So you have here appendix, appendicle, vaso or base, of blood, hemo, bone marrow, myelo. Take note na different na siya sa Miyingo cell, no? Clotting, thrombo, clotting, agglutinin, disease, patho, it, swallow, phago, fever, fibro. So these are the basic terms and these are the meaning, no? Or combining form, no? Ano yung meaning sa combining form niya. So morpho, shapes, zero means serum, thymos, and then you have your prefixes. When you say without, anti means against, enter means between, mono means one, poly means many, two before. So we have also suffixes. Okay, so these are the suffixes. No? So when you say erythropoiesis, that is erythro, red. Cool. So, nana. So these are the diseases. No? We're going to discuss cardiovascular system. This topic coincides also with our topic in anatomy, which talk about the anatomy of the heart and lungs. Okay, so in cardiovascular system, the primary function of this is provides means of transportation. As I mentioned in anatomy and physiology in anatomy class, that basically they transport nutrients, oxygen, hormones, and body salts in waste all over the body, as well as protective mechanism. Okay. So the cardiovascular system is able to transport this because of the presence of blood. Like, we discussed this just a while ago. Okay, so here this is the graph of the uh, circulation or the cardiovascular system. So we have here the flow starts from the right side of the heart, which is the atrium. This is the receiving chamber of the heart. It receives unoxygenated blood coming from the system, okay, from the inferior and superior vena cava. Then after that, the blood goes to the right ventricle. It is being pumped by the right ventricle towards the lungs via the pulmonary artery. Okay, so it passes through valves, which is your tricuspid between the atrium and ventricles and the aortic semilunar valve. Oh no, pulmonic semilunar valve, which Uh, it is found at the base of the pulmonary artery. It prevents backing flow of blood from the lungs to the right ventricle. Then, with that blood reaches the lungs, it is being oxygenated by means of simple diffusion. So, by means of through the concentration gradient or concentration difference between the gases, oxygen and carbon dioxide. So the carbon dioxide goes out from the blood vessel or from the capillaries to the alveoli, while the oxygen goes in from the alveoli to the capillaries. Then after that, this blood will be go through your pulmonary veins, then goes to the receiving chamber again of the heart, which is the left atrium. It receives oxygenated blood coming from the lungs. Then it will pass the mitral valve, then to the left ventricle. Then it will be pumped out to the aorta, passing the aortic semilunar valve. Then from the aorta, it will be distributed uh, through your different parts of the body. We call this as your systemic circulation. Okay, then there, when it reaches the tissues, it will undergo internal respiration or exchange of gases between the tissues and the capillaries. So in the lungs, we have what we call external respiration or exchange of gases between external environment and the capillaries. Okay, so we have two types of circulation, as I mentioned, pulmonary and systemic. So the pulmonary circulation uh, begins with the right side of the heart and ends with the uh, pulmonary vein. No? Then the systemic circulation uh, starts from the left side of the heart, which is in the left ventricle area, no? And going to the tissues for the distribution of oxygen. So we have here oxygen. So it comes from the word oxy. Okay. So carbon dioxide, ang word niya ana is capnia. So when you say hypercapnia means there's an excess of carbon dioxide in the blood. Hypocapnia, lack of carbon dioxide. So we have here the heart, cardio. So yung mga anatomical term. So during systemic circulation, the blood passes through the kidney. What is the primary function of the kidney? The kidney uh, let's say renal circulation. So purpose ng kidney is filter, no? So kidney, ang iyang anatomical term is nephro. So they have also the liver. So then you have your pulmono or lungs. So sa kidney, pinafilter na niya ang imuhang oxygenated blood. Ang sulod dito iya pa nang i-filter, no? Para ma-remove ang mga waste. Okay? As we all know, ang blood nga gikan sa right side sa heart carries all the waste including the liquid. So pag abot sa lungs, dili na siya ito ma-remove ang waste. Ang ma-remove lang ito is the gas. Okay? So pag pump sa imong heart, sa imong blood, left side, ang magawa sa aorta, although it is already oxygenated, pero napa na siya yung mga liquid waste. So asa na siya ma-remove pag abot na niya dito sa kidney. So i-remove na siya dito ang liquid waste. Urea, no? Uh, katonghini, uh, na part, no? Sa blood, dito na siya magawas. Okay. So, nana na siya. So we have also what we call portal circulation. Kaning portal circulation, it comes from your uh, internal organs, no? So especially sa Ugon sa imong abdominal cavity. So, sama na siya. No? So, all blood mag-return siya sa heart coming from your internal organs, so coming from your abdominal cavity or abdominal organs. All of these are unoxygenated. But, no, especially coming from the mesenteric vein, unoxygenated food siya, pero it is uh, full of nutrients. Kaya nga naman, why? So, dito sa imong small intestine, di ba, di ama dito ang major absorption of the nutrients, especially in the duodenum. So, naan man dira connected na siya sa mesenteric vein. Then, this blood, nag-drain niya dito, unoxygenated na siya, but it contains a lot of nutrients. So, before going to the heart, it will pass first to the liver. The liver will be the one to detoxify this. Okay, and yung function ng sa liver is this detoxification. So whatever toxic na nakaon na to, yan ang kwaon. No? Alcohol, maon sa padira, yan ang kwaon. Golding, kung nakaon dito mga sa pa mga red tide o mga sa padira. So i-remove niya, no? Pag remove niya, ipagawas na niya sa ang iyang portal circulation. Magawas na, musulod siya dito sa inferior vena cava. Okay. So, ang blood itong musulod sa inferior vena cava, unoxygenated to na siya, pero full of nutrients. Okay. So, ma-distribute na siya only after ma-oxygenate. Then, from oxygenation, then musulod siya sa heart, then ipang. No, ayan na siya ma-distribute ang nutrients na ito. Ang liver not only detoxifying, it's also stores, no? So, paano naman to niya din dito, mga importante nga. Let's take for example, fats, mga na, i-convert niya into glycogen, mga sa, so, ano na yung function sa liver. Okay? So, sa systemic circulation, na dito, natay parts, no? Sa systemic circulation or pulmonary circulation, naagin na siya dito sa blood vessel. Okay, so ang blood vessel, kung ito tanawon, if you're going to look at it, so we have here the artery and veins. So of course, a difference between the two is the arteries is as a thick na muscular layer, ang veins po, extra. Pero ang veins na valve, ang artery wala. Okay? And if you take a look at it, as a several layers ang imong artery or ang imong blood vessel. So you have your outer layer, which is your adventitia, muscular layer, which is your tunica media, and uh, inner layer, so which is the tunica intima. Okay, so then you have your serosa. Ato pag yun sa surface. Okay, so which is the endothelium or the so aorta, these are large arteries, then artery, then arterioles, then capillaries. Then you have your venules, then your veins. Okay. So, inana. So, here you can find the term na ginagamit niya, aorta, aorto, vessel, vasculo, angio, vaso. So, if you see this word, vasculo, vaso, angio, that refers to vessel. Artery din, arterial. No? Or arteries din siya. Venule, venule, or vein, you have your plavo. So, when you say phlebotomist, these are individuals who gather blood through the vein, no? Ano na sila. So here, I'll make this one also as an assignment. So here, naana diri ang layers sa heart. So discuss na to. So there is a precordium which is the area where the heart or the base of the heart is located. Tawag siya nga precordium. Okay, so ang apex niya, oho, sa anatomy, ako na nang na-discuss nga, it points to the left side of the heart. Kaya ang base points sa right shoulder. So, ang atrium or atrium, na siya leaflets or auricular. Okay? Are the term that needs to be noted. Okay? Trabecular, valve, septum, endocardium, myocardium, pericardium. So, myocardium, that is the muscular, kay myelin, peri, that's the outer layer. Then AP, ano siya ay uh, ang katong uh, katong tissue nga pinaka-outermost, no? Equivalent to yung parietal pericardium na ang epicardium. Okay, then yung transmural trans to wall, okay, pertaining to. So, ano siya? So, ang imong heart nasa trochal layers, distinctive layers. So, blood vessel up, upat, diba? Like adventitia, media, intima, then you have your serosa. Oh, okay, so ina na. So, sa imong one is to look ang inner, which is your endocardium. Kanang endocardium is continuous layer of the endothelium or the inner layer of the blood vessel. It is so smooth, no? Then your myocardium, that is muscular. Then your pericardium, so, double folded layer of connective tissue. Ano siya dito, ang visceral ni mga pericardium, equivalent sa epicardium. Then, ang imuhang uh, parietal pericardium. Okay. So, ina na siya. Sumunod siya ang heart. So, makita niyo ang wall sa heart is ang sa right ventricle is nipis, ang sa left is baga. Baga na siya ang muscular layer sa left ventricle because of the work load na nahatag niya. Imagine, nag-pump siya sa blood to the systemic circulation. So, all throughout sa imong body, which equivalent to about 700 miles of blood vessel. So, and then, ang imong right side, medyo gamay ang ihang muscular kaya simple, the-pump lang na siya towards the lungs ra. Diba? So, yan na. Kung tanawin mo siya ang parts sa heart. So, you have here the right atrium, then your right ventricle. This is the pulmonary artery. Then you have your left atrium, mitral valve, then your left ventricle, the pump na siya through your aorta. Okay? So, the branches of your aorta is your finish siya. Left, right, right subclavian, uh, cephalic rather, internal carotid, your right internal carotid. Now, left internal carotid, kini sa right man, ang right internal carotid, diri siya mura sa brachycephalic. Then you have your, kini siya, this is left brachycephalic, then subclavian. So, yan na siya. So, kani, ano siya yung mga branches. Pero na ito ang ihang okay. Kanang illustration, kanang color niya red and blue. Kanang blue, signifies na nga, kanang mga agi dira ng mga blood is unoxygenated. Kanang red, nag-agi dira is oxygenated blood. Mao pag siya ang appearance sa blood. If it is unoxygenated, ang iyang pagka-red is dull, no? Medyo may pagka-maroon ang iyang pagka-pula. So kung oxygenated na siya, ang iyang itsura na is bright red. No? ang color sa so ano siya no tricuspid 3 cusp point feed pertaining to so semi half moon so semilunar by 2 mana siya so di ba perfect man. So kanimong tan-awon ako lang kasi ang imong leaflet sa imo ano oh yeah leaflet sa imong valve especially by full speed and tricuspid ano siya naka-attach na kanang murag string no call this chordotendinae kani chordotendinae naka-attach dito sa papillary muscles ang primary functions ng chordotendinae is to prevent the backward opening of the valve during ventricular contraction so para di siya mag-open dito sa atrium para di mag-backflow ang blood so ano siya so naka-attach na siya sa papillary muscles na naa sa wall sa imong heart. So, kaya siya. No? Na, word like that. So, kung ang imong heart na contract, each contraction we call that as stroke. No? Stroke volume. So, ano siya. So, kanang yung kitang paggawas na blood, each contraction sa imong left ventricle and right ventricle going to the lungs and going to the systemic circulation. We call that as ejection fraction of cardiac output. So, kada beat niya, na siya amount sa blood niya ginapagawas. Imagine ang atong heart na isa 80 beats per minute. So, that is the average. So, according to some book, each cardiac output, stroke volume kuno is equivalent to uh, times 80, equivalent to 70 ml. 70 ml kada contract sa imong heart, ginapagawas niya nga blood sa left ventricle going systemic and right ventricle going to the pulmonary circuit is equivalent to 70 ml. Okay? So, that is one stroke volume. So, since ang imong uh, stroke volume is 70 ml, you multiply it by 80 beats per minute, which is the average beats of the heart per minute. So, that is equivalent to 5,600 ml. Or that is equivalent to the total volume of the heart, or that is equivalent to the cardiac output also. Or total volume, blood volume, or equivalent to cardiac output. So in 1 minute, actually, your total blood volume is being pumped out by the heart, no, per minute. Ana na siya. So ina na siya. So ina na siya imong heart. So this we have the coronary circulation. Okay, supplying the walls of the heart. So you have your left coronary artery. So kana siyang left coronary and right coronary artery nag-rise na siya dito sa base sa imong aorta. So pag pump sa blood niya pagawas, dira na siya dayon mo ka button of blood supply no ang imong heart tissue. So then you have your coronary vein po. Kini coronary vein iyahang base ani no, na dito sa superior vena cava. No? So, ang all waste product sa cardiac tissue, i-drain na siya balik dito sa superior vena cava. Okay. So, ano na siya. So, sa mga cardiac arrest, may cardiac infarction. So, ano siya nga blood vessel ay na coronary artery mo ni mabara. So, kung nasa tong bara, ang katong ginasuplayan niya nga area mo ito yung apektuhan. No? Mga isa din ko na kay myocardial infarction sa left side, sa heart, sa right side sa heart. So, so these are the branches of your uh, coronary artery. So, gikan sa ascending aorta dito sa base, mag-divide na siya into two. Kaya sa left coronary, ano yung nasumplayan, ano yung mga area. So you have your left anterior intraventricular na artery. Supply na siya sa ventricular area. Then circumflex branch, kanang circumflex, nag-meet na siya dito sa imuhang uh, right, okay, circumflex man at nag-circular siya sa heart, din nag-connect na siya dito, no? Nag-capillaries nga nag-meet anak dito sa right side sa heart. No? Ang purpose na niya para ma-maintain ang enough blood supply sa heart in case na ay mga infarction nga mga dugo. So, mo yung mga branches sa imong left coronary artery, mo yung branches sa right coronary artery. Okay. So, you have also your conductive mechanism system. So, ang heart na to, ano siya kagaling yung conductive system. Si conductive system, ga-conduct na siya ga-function na siya iyaha. Independent na siya sa ato ang uh, brain. No? Dili na siya makomandan kaya involuntary na siya. So na siya kagalingan nag-generate siya electrical signal, no? Wala nag-generate ang wala na ang electrical signal nga ga-stimulate sa heart para mag-beat, wala nag-originate sa brain, nag-originate sa cardiac tissue itself, which is found in your sinoatrial area or in your atrium, no? Itawag ko siya nga sinoatrial node. Okay? So, inana siya. We call that as your uh, natural pacemaker of the heart or natural cardiac pacemaker ang SNO. So, as your heart pumps blood, itong blood nga flow sa mong artery, no? Mag-abot siya sa mga areas where palpable na siya. We call those as pulses. Now, pulses, these are the wave or palpable wave of blood in your arteries. So, asa man nato mapalpate na ang mga pulses, ang wave sa blood. So, each stroke volume, equivalent ko na siya sa isa heartbeat na. So, nan siya wave na produce. So, you have here the temporal, this agtang, facial, then carotid, brachial, radial, ulnar, inguinal, or femoral, popliteal, posterior tibial artery, then dorsalis pedis. So, muna siya yung mga areas kung nasa mapalpit na to ang pulse. Ano siya? Ano siya? So, di ba? Anak-anak man ka sa finger ni mo sa radial nga side. Kung na po na pulse sa left sa imong ulna. Okay, so remember na when you are using to count the pulse, don't use the thumb kaya yung thumb itself na na siya pulse, so it might be nga sa ipag-count. So, gamito nimo ang index o ang middle finger, no, para pagpalpit sa pulse. Okay. So, kaya na ako ang diskutan nga sa node, no, conductive mechanism sa heart. So, dito sa is A, which is really sa right, ano siya branch, tapos dito sa right, left atrium. Then, nag-converge na siya dito sa AV node. Then, sa imong bundle of branch o bundle of his. Yung bundle of branch, 14 fiber. So, ano siya? Sa each of these area, na siya kabaling yung rhythm sa pag-fire sa electrical signal. Yung nga, yung pinakataas na rate sa pag-fire is your SA node, which is about 60 to 80. EV is followed, nagasunod ang EV, it's about 45 to 50 or 45 to 60. Mas much slower din ang bundle branches, mas mubo pa yun. Okay? Ang purpose ana niya, kung nganong naa sila independent firing signal, in case nga ang katong na ipinakataas nga firing rate mo damage, maka-take over pa ni ang sunod nga node, no, sa pag-fire sa electrical signal para dili dayon mapalong ang heart. But as long as functional ang imong SA node, the rest of the node of the heart will follow the one that has the higher rate of firing of electrical signal, which is the AC node. So, yun. So, unsa may ginagamit para mag-read sa uh, electrical conductivity sa heart, which it is your electrocardiogram. So, it is an instrument, no, para mag-read sa electrical conductivity sa heart. So, from the word electricity, no, electro, in cardio, heart, gram, recording. So, electrocardiogram, recording of the electrical activity of the heart. So, muna siya ang imong kuhan sa ECG. So, ang wave, makita niyo siya sa ECG. So, siya P, Q, R, S. Kaya siya ginatawag niyo siya nga QRS interval or QRS index. Then you have your T wave. So, muna siya makita sa LED 3 sa imong ECG. So, muna siya common nga appearance. So, kani siya class, ang pag-read ani, anang to si cardiopulmonary nga kung ano, ang tanan nato siya, no? Sa cardiopulmonary conditions. Ma-studyhan nato siya ang pagbasa sa theory o sa ECG rather, no? Or EKG in other one. So, ano siya. So, mga mabaw na to niya siya kung kana siya STEMI or non-STEMI. Or STEMI means stable sila na siya. Stable electrocardiogram. Basta may ano kay myocardial infarction. Ano siya ang NSTMI kay non-stable. No? So kani ako po din siya ang himong activity, no, para sa heart. Okay? So you have the arteries. So ang arteries na to na siya kalayan, di ba? Aorta, no? Paggawas ana sa aorta dito sa imong diaphragm. Dili na sa aorta. Tinatawag na siya dahil nga abdominal artery. No? Dito na siya dahil sa artery. Okay. Then mga branch na siya dahil ang abdominal artery. Kaya na siya sa mesenteric. Ito sa internal organs. No? Kaya na sa renal. Mga branch na siya. Then mag-split sa to into iliac. Then from the iliac, may ano siya pagawasin sa inguinal ligament femoral. No? So, na siya. Ang mga branch arteries na to. So, ina niyo. So, here, ano siya, ang first na niya sa imong kuan, you have here the right internal thoracic artery. Then, kuan na siya sa subclavian. Then, from the subclavian, advance na siya sa common carotid. Dili, mag-left common carotid, direkta na siya dito sa aorta. Then, dili, makita pa din nato ang left subclavian. So, kani siya, power siya brachiocephalic. Brachiocephalic, then subclavian. So, right brachiocephalic, subclavian, carotid, right common carotid, then left common carotid. So, trivial lang class, inani. Usually, ang common nga magka-problema gyud ang left side sa na kung ma-stroke ka, may mabantayan nyo, mga stroke patient, makita nyo nga kasagara ang problemado nila is the right side of their body. Na namang right side. Because usually, ang involved ka artery is your left common carotid artery. Kaya nga naman, ang left common carotid artery is a direct branch coming from your aorta. So, dako siya kaysa left common carotid, right common carotid. Ang right common carotid, gikan pa na siya sa brachiocephalic. Sa right brachiocephalic. So, direct branch. So, usually, mga embolism, musubay na siya dito sa Tako o blood vessels. So usually active na saka, kaya sa right side sa left side sa inyong brain. So kung dito siya sa left side niya sa inyong brain, ang affected na ang right side. So muna ang mga mas common ang mga right side weakness, no? Which is ano ibot kasabot nga left side sa brain ang affected. So ina na. Then yung here yung brachial artery. Then from the brachial, madivide sa two, pharyngeal and ulnar. No? So, sa taas, sa brain, makita pag natin dito ang circle of Willis. Okay? Lower arteries, inamin na siya class. Arteries, inamin mga branches. So, dito sa abdominal aorta, mag-branch na siya, no? Renal, tayo sa liver, nanadre suprarenal, left suprarenal, dire siya, pinakahayos yun na siya, tayo siya sa kidney. Then sunod, para siya sa celiac, paingon siya sa lapay, pancreas, celiac artery. Then hepatic, paingon sa liver, splenic, paingon sa spleen, then gastric, sa pikas na side. Okay. Yan, superior mesenteric, paingon siya sa imuhang, ang inferior mesenteric, paingon na siya sa imong liges sa imong intestine. Then right colic, and left colic. So colic man na siya, paingon siya sa colon, which is in your digestive digestive. Your intestine, rather. Have here the common iliac, then iliac, and you have now your femoral. So, nga na siya mga branches sa artery nato. Paingon na siya dito sa femoral, mga branch na siya into popliteal, then mag-branch into and peroneal. Kanya fibula, foot, widow, ankle, so two finger digits. May mga branches na sa artery. Sa veins, mga siyang branches sa upper veins, superior vena cava. So you have here, mga magana sila sa artery. Yeah. So look, tanawan niyo. Basilic, brachial, pero na lang siya mga additional. Tibital, radial, ulnar, so mga branches. No? Then, Flavian vein, sunod na siya sa Flavian. Kaya na sila tanan dito sa superior vena. Ato lang, don't be confused. Ang cephalic veins is in the arm, not in the head. Don't confuse the basilic vein in the lower na to, lower veins mo ni hepatic portal circulation. Portal vein, kaya this is the kidney, nasa liver, gikan sa liver, kaya mo siya sa kidney. Ang kaning portal vein rather, hindi ka na siya sa imong mesenteric vein nga nag-drain sa blood gikan sa intestine. O kung imong tanawon na connected siya tanan sa colic, superior mesenteric. So tanawin na adra nga mga kuan na drain na siya pa ingon dito sa imong portal vein, di masulod siya sa liver. From the liver, mugawas na siya paingon sa hepatic vein. Kaya di ba, mag-store pa man siya o mag-detoxify. Okay, so pagkabot na dito, pag kumain yung detoxify, masulod na siya sa hepatic vein. Sulod sa inferior vena cava. Ano na say, flow. Okay. So, all veins, gikan sa abdominal organs. Nagsulod na sila sa portal vein. Then from portal vein going to the liver, then from the liver to hepatic vein to inferior vena cava. Then to the right side or inferior side of the right atrium. So muna siya mga branches sa vein class. So kung pareho ra gid na sila sa artery. Ang problema, ang kalahian lang kay ang veins gidala siya sa blood back sa heart and it is unoxygenated and na siya valve. Ang artery wala. Ang function sa valve para di siya mag-backflow. Okay, siyempre gravity dependent na ang blood sa veins. So, paano siya mag-pump sa blood back to the heart? It is through your muscular contraction. So, kung mo siyang pakontract ang inyong muscle, example, ankle pumping, you always walk, you always run. So, it means to say that your venous return is very efficient. No? Mabalik ang blood sa heart. So, kung wala ka pa-contract sa imong blood vessel, steady lang ka, so you're prone to hemostasis. Ano sa manang hemostasis, di ba? Hemostasis. Magkuhan siya ang imong blood. Kaya hemostasis stoppage mo dito. Mag-stagnant ang imong blood sa imong veins. No? Mag-engorge ang veins. So sometimes, kung daot ang valve, mo na mag-result siya sa magburot siya, mag-varicosis. Or sometimes, kung dili varicosis, manag maghupong ang tail nimo. So mabitaw na uban. Tingala ka pa when you wake up, when you wear your shoes, igo siya. Now, after na mag-feel nimo nga murag nihuot imong sapatos, murag swollen ang imong foot because of the wala kayo siya magbalag, mag-circulate ang imong dugo gikan sa lower veins. So, imo siyang i-elevate or i-pump nimo, ilihok, magtindog ka. Importante kayo ang mobility. So, sige kuya. Okay, so diri lang taman sa akong lecture ani. So anyway, I'll be going to add additional lectures sa intro to PT pa next week. So at least I have 3 lectures na akong i-discuss sa meeting online.